Right, hello everyone. So today we are going to learn about what affects the strength of an intermolecular force attraction. So we have just learned, right, that intermolecular force attraction is between neutral molecules. That means things that has no charge, right? So we are looking at particles that have no charge, so there's attraction. So one of these factors, there are many factors that affect the strength of these intermolecular forces, but the one that we want to look at is the number of electrons in the molecule, the whole molecule. How many electrons are there? So at secondary school, we can sort of loosely say that as the molecular mass increases, the number of electrons actually increases. Because the more mass it has, that's the more electrons we have. So the more electrons we have, the strength of the intermolecular forces increases. So loosely, we can remember this trend. So if the molecular mass of a molecule increases, the strength of the intermolecular forces increases. So bigger the molecule, the stronger the intermolecular force. So let's look at these two examples. Here we got hydrogen and with oxygen. Which one would be stronger? So we can see that hydrogen has a molecular mass of 2, while oxygen have a relative molecular mass of 16 times 2, which is 32. So we can see that oxygen is bigger. So oxygen is bigger because it has a higher molecular mass. Always remember to code in data, right? Data is very important. So O2 has a higher molecular mass, so therefore O2 has stronger intermolecular forces of attraction, more energy required to overcome the stronger intermolecular force of attraction, so O2 should have a higher boiling point. Alright, so now let's look at the next example. We've got water. Water is 18 relative molecular mass. Now, polyester, we are going to talk about it now, is what we call a macromolecule. Now, a macromolecule is a very big molecule, right? It's still a molecule, right? That means I still have like individual of them, but it's very big. And polyester is a type of plastic. And because polyester is a very big molecule, polyester, right, has a high relative molecular mass. So because it has a very high relative molecular mass, right, the strength of the intermolecular forces of attraction is very high. So a lot of energy is required to overcome these intermolecular forces. Okay, so let's take a look at this new structure that we have learned. So macromolecules, right? So macromolecules are generally plastic. So you have things like nylon, you think like polyester, okay, plastics, right? So the melting point of macromolecules is actually very high, right? You see plastics are usually solid, right? And they're usually solid at room temperature because these melting points are very high. So plastic is also a molecule, right? And as what we remember, for our simple covalent molecules do not conduct electricity in any state, right? They do not conduct electricity in any state. And macromolecules are the same. They do not conduct electricity in any state because they are still molecules and there are no free moving ions or free moving electrons, right? And because they are still molecules but very big ones, right, they are also not soluble in water. They are soluble in organic solvent. So what are the particles, right, or elements that are present first? So again, they are molecules, so they are made up of mainly non-metals, right? And the particles are actually big molecules. So they are macromolecules, big molecules. They are made up of atoms that are covalently bonded together. So very similar to a covalent molecule. Okay, and the bonding is also very similar. There are very strong covalent bonds, right, between the atoms. And as compared to a simple molecule, because the molecular mass is bigger, there are actually stronger intermolecular forces of attraction, right, between the molecules. So because they are big molecules, right, so these big molecules, the structure is actually big molecules held together by stronger intermolecular forces of attraction. All right, so let's take a look at how we can write a certain explanation. Okay, so let's take a look. So let's explain why plastic is a solid while carbon dioxide is a gas. So we can say that since plastic is a macromolecule, right, a very big molecule, and has a very high molecular mass, right, while carbon dioxide is a simple covalent molecule with a low molecular mass. And remember to give data, right, MR or RMM44, and as more energy is required to overcome, because we are talking about attraction here, so overcome the stronger intermolecular forces of attraction in plastic as compared to carbon dioxide. So therefore plastic is a solid and carbon dioxide is a gas. Okay, so I hope you have learned on what affects the strength of an intermolecular force, right, as well as you learn about the properties and structures of a macromolecule. Alright, so thank you very much and I'll see you for the next video. Bye!